know me or haven't seen me before, so I'm, as noted there, Greg at SQLDay.com. This session is on things that I wish developers knew about SQL Server. And so first up, I actually want to thank the sponsors, because without that, these sort of events couldn't occur at all. And the first warning I'll give you, actually, I've used a few baseball analogies here in the screenshots, and I know that's kind of a strange thing for an Australian, which is what I am, but I grew up playing baseball, and in later years I spent a lot of time umpiring baseball, so it's actually a bit of a passion of mine, which is a peculiar thing for an Australian, but anyway. So look, I do want to warn you that you may not agree with everything I say in the session. I just tell you that straight up. And the thing though is it's not just my opinion when I've put these things together. These are things that, you know, I discuss with lots of MVPs and customers and people over a very, very long period of time. And these are issues that I've seen come up just time and again, and I really wish that developers in general just understood about SQL Server. And so what I want to do, I mean, feel free to just use or disregard as you see fit. And so, as I said, you may not agree, take what you want out of the session. And so look, who I am, I'm Greg, I'm the founder at SQL Down Under. I'm the principal mentor there as well. And I'm a long-term data platform MVP. I've been in the data platform MVP group for, or what used to be that group, along the way for about just on 20 years now, so a long time. And I'm a member of the Microsoft Regional Director Program, and I normally describe that to people as it gets me on a whole lot of interesting mailing lists within Microsoft, and I can't always tell people why I give them the advice I do in terms of directions of products and things, but there's usually a good reason, because I'm part of groups and things where I usually have a pretty good idea where things are going. I was a certified master, and still am, I suppose, for SQL Server, and I was an instructor in that program when we had the certified master program. And I do a lot of writing, right? So I've got STU Tools, a free tool set, and written a whole bunch of books and ebooks, and I have white papers and webinars and podcasts and so on, a whole bunch of things. But what I want to cover off, there are 6 specific areas that I want to mention, and then also just finish it up with some sort of general design advice. And so the first thing is around code smells. And so these are situations where we see something in code and it indicates to us that there isn't necessarily something wrong, there is probably something wrong. And so we'll start with a few of those, right? So the most common general code smells that I run into, first up, obviously, is the extensive use of cursors, right? So when I first come to a system, and often I get involved because they are having performance problems and things like that, and if I look at how the applications are dealing with the server, one of the most common things you see is a whole bunch of cursors, and particularly cursors using default options, and a whole lot of temporary tables. That's another very, very common one. Now, a lot of people who've come from other database engines, like they work with Oracle and things like that, they've been encouraged to make use of cursors. In general, we tend to avoid using cursors. I don't not use them, but mostly where I use them is in things like utilities and so on, not in general application code. It would be a very rare day when I would use a cursor in typical application code. But if you have got a situation where you're using cursors and maybe you've having to look after code that somebody else wrote or things like that, the other thing I want you to do, though, is have a look at the options that you're using for the cursors. So to give you an example, there's an application in Australia that's used by many local government, local councils, and they use it all over the country. And whenever I go to any council, they tell me how slow the application is. When I do tracing and I look at how it talks to the database, invariably they're using cursors all the time. The worst part is they use the default options for cursors. And the default option for a cursor is static. So that means that every time they just go to read data, what they're doing is taking a copy of all of the data and pushing it into TempDB before they then start retrieving it back out of TempDB. That is a horrible thing to be doing. And in the case of this application, they just don't need to be doing that when I look at how they then use the rest of the code. In fact, if all they did was change the cursor to fast forward read only, then the whole thing would run about 10 times faster. But again, the problem with a lot of third-party applications is if I go and talk to the vendors and I try and send them information and say, hey, this would be so much faster if you just changed it, all you get is you end up with a brick wall where you end up with a sales team who really don't want to discuss it, and they just say, look, no other council is having a problem. And I mean, it's not true. I mean, I know that because I work for other councils as well. But the thing is that they just don't want to hear it. But so if you are using that, that's important. A second one is temporary tables. And so if I see a whole lot of temporary tables being used in code, often because the person is thinking quite procedurally about how they're building, and usually not very set-based, how they're building the code. Now, there are some times when temporary tables are a good option. Now, I see situations where people use common table expressions and they use layers on layers on layers on layers, and the optimizer in SQL Server can lose the plot. It can not know what's going on, and sometimes materializing the data into a temporary table will let it get statistics and things so it can then continue on okay. But what I often hear is I see people using table variables, and the problem is they often refer to them as memory tables or memory-based tables. And it's important to understand that table variables are not memory-based, right? I mean, most of the time they end up on the disk in TempDB just like temporary tables do. They also have a few other sort of odd characteristics in that they don't tend to have much in the way of statistics associated with them. They can have cardinality stats, but they tend to have nothing else. And there used to be a Microsoft best practices analyzer that every time it used to see you using a temporary table, it would suggest you change it to a table variable. And because that would stop it causing recompiles. But of course, the problem with that is that was actually terrible advice, because the reason it doesn't cause recompiles is it doesn't have statistics. So if you change your temporary tables to use table variables, then what you'd end up with is a situation where you don't have recompiles happening, but you have very slow queries running. Look, in general, when you're trying to pick between the two, table variables work well with very small numbers of rows, a dozen rows, half a dozen rows, things like that. The further you go up with the number of rows, the worse you're going to end up performance-wise with those. And temporary tables will actually work better with larger amounts. The other main difference between the two, of course, is temporary tables are transactional, where table variables are not. So if you do, any time you do a rollback, the value that's in a table variable will stay there. But anyway, a very common code smell is that I see a lot of cursors and a lot of temporary tables. Another one is where people have extensive use of triggers throughout their code. Now, again, there's nothing per se that's wrong with triggers as in general, but you do not want to implement a great deal of your logic in triggers. We use triggers, but we tend to use them as an exception rather than as part of the normal processing. And another thing that's very different about SQL Server is that when you build a trigger, if a statement affects a number of rows, then the trigger fires once and it gives you details of all the rows that have changed. I see people who write triggers and they've only thought about if a single row is being modified. And a very telltale sign of that is you look at the trigger code and you'll see they have code that says things like set some variable equals, and then they select a value, from the inserted table or something. You've really got to keep in mind all the time that when you're writing triggers, that you are writing them to process all the rows at the same time, not single rows. TSQL functions, Scalar functions in TSQL allow you to build your own functions and things, but unfortunately over the years the performance of these has been appallingly bad. And so if you have a Scalar function, so one that just takes some values and returns back a single value, you'll find that if you put that in a select clause or you put that in a where clause, then you have probably completely demolished the performance of your query. And often taking the code out of the function and just putting it back in the select clause or the where clause, you'll find that it runs really, really quickly. And so that's an unfortunate thing. I wish it did not work that way, but that's how things are. And so we often improve the performance of SQL code markedly by replacing TSQL functions with inline code. Now, in SQL Server, in recent versions, particularly now in SQL Server 2019, they have done a lot of work to try and inline Scalar UDFs, and they have tried to improve the performance of that, and they've done a great job. There's an academic paper about a thing called Freud, F-R-O-I-D, and that describes the mechanisms they've used for this. But it's still, as a general rule, this is not what you want to have if you're trying to have TSQL functions that run at a reasonable speed. Another one is where you have a whole lot of dynamic SQL code. And this can be problematic too, in that what people often end up with is not very well formed code. And the problem is that as soon as you start mixing code and data, which is often what you end up doing with dynamic SQL, the problem is that it's very easy to have things go wrong. And to give you one that I thought was pretty funny, I saw this many years ago. So it was August 2007. But notice these are milk chocolate coated raisins, and they've got all the ingredients, but notice the ingredients included select Asta from equipment table, where equipment ID is 4, right? So this is silly. So somehow the query has ended up becoming part of the data. And this is the sort of thing that can go wrong if you just slightly mess up dynamic code. Now, some more specific code smells. If I see code where people have top 100% in the code, that's usually an indication that something's gone wrong in their thinking about the code. And this is because tables and views don't have a default order, but people are often doing this to try and apply an order to a query. And on a similar note, you've got to be very, very careful if you have not in clauses and you have a list of values that could be nullable. Now, let me just show you this for a minute. All right, so I'll try and push that up to a pretty big size. We'll see how we go. Now, if I have a query, I've got wide world importers here. So if I said, look, let me do select from, let's go warehouse stock items, SI, and I'll just grab a couple of columns here, like let's say SI stock item ID and SI stock item name. So I've got a query like this, and it's just a list of them, but I want to have this ordered by the stock item name, right? Now, that's fine as a query, that's okay. But where the problem comes in is somebody decides they want to create this as a view, and so what they'll do is they'll say create view as ordered stock items as this, and then when they try and execute this, it says no, you can't do that. And so what it's saying is the order by clause is invalid in views, inline functions, derived tables, subqueries, and common table expressions. But then it says, unless top, offset, or XML is specified. So what people then did is they went, oh, well, I can fix that. So I just put in their top 100% because I want all the rows. And then you notice when you create this, it then creates it okay, right? And so the problem is that someone's trying to create an ordered view. And there is no such thing in SQL Server as an ordered view. And when they, in early versions back in SQL Server 2000, this used to work, and you'd get a view that returned the data in that order. But that was a quirk of how they had implemented it at the time. And that got fixed somewhere around about SQL Server 2005 or 2008. And then people started complaining that the views weren't returning the data in order. But of course, they should never have done that in the first place. But what they did is they started using the top statement and the order by here. So that order by was just being used to implement the top statement. And then the rows could be returned in any order at all once they had been selected. And so that actually didn't work like people were expecting. So as soon as we see top 100% in code, I just know that someone's probably trying to make an ordered view. Now, another thing to show you here, if I get here, I was saying about nullable clauses. So if I said, look, where SI stock item ID is in a list where I have no idea what values are in there, let's have a look. Okay, so if I said, look, give me the ones where it's 89, 99 and 100. And so I just do that. Then I get back the 3 rows and you think, well, that's fine. That makes sense. If I had null in this list, then you can think, well, what would come back from that, right? And no surprise, it's exactly the same rows. However, if I change this query and I said where it's not in, and I've got these 3 here, so if I look at the total number of rows, which we can see down here is 227, and I execute this with the not in, then that sort of works as expected, and the number of rows is 224. Where people come unstuck with not in is if there's any chance that this query or this clause could have a value that's null, then things go very wrong. So notice if I have null in here and you think, well, what would that return? Most people are sort of assuming that that'll return the same rows. But when you execute that, notice nothing comes back. Right? And that's because this clause only passes if the value is true. And if you have any situation where you've got a value where, something equals null, the problem is that's never true, right? Unless you fiddle with the settings and things. Because when you have a value here and a value that's null, the answer to this is null. It's never true or false. And so the problem is that when you have a not in clause like that, you've got to be super careful if this is a subquery to make sure that that will never return a null value, or you'll see something very different to what you had in mind. All right. All those. Now, next thing is about loving your data. So there are a whole lot of things about how you design systems. Now, clearly, we could argue for weeks about how naming needs to happen. There is no correct answer for this. Now, I have some personal preferences about how that works, but obviously being consistent is the number one thing. But one thing I'd encourage you not to do is to head down the path of prefixes. I try and avoid them all the time. And so, for example, if we look back here, in things like AdventureWorks, Microsoft had schemas in place that were being used to group the tables, right? Notice when they got to data warehouse version, so what they've done here is they've got dim and fact as prefixes. Now, a lot of the BI people still do this today, right? But the bottom line is that when you have a prefix like that on a table, then what you're doing is you're trying to use it to group things together, in some way. And so back when they first did this in the Kimball stuff and so on, we didn't have schemas. But the thing is, if you see a whole lot of tables that have the same prefix, that would be much better as a schema. So I'd rather have fact dot and then call center and fact dot currency rate and so on. That would be a lot better in terms of the naming. But the other thing I see people do is that when they define tables, they will have TBL customer or something like this. And this will be usually because they come from an access background or something like that, where that was common. They'll also put view or something in front of, customer views and so on. The problem with this, and now it seems really, really simple when you first start doing it, and they might, the problem you can run into is that as systems evolve, and systems are a bit complicated, you can end up having to change the nature of the object. So I might have, for example, a table, and I need to do maintenance, so I need to replace it with a view, but I'm not game to change the name of the table. So I come across views that are called TBL customer and so on. And even Microsoft themselves have fallen foul of this, right? So if you look in the system databases, in the master database, we've got under stored procedures, we've got system stored procs, right? Now, the system stored procs, when they first did this, they were all named SP underscore something. That was the name of all of these system stored procs. So SP underscore something. And there were also extended stored procedures, so system ones of those. And they, when they first did all these, had XP as a prefix. So you'd say, well, hey, that's great. Problem is, it was because they were implemented in a different way. But down the track, what happened is they had to change it. They weren't prepared to change the name of the object because so many things were using it. And so what happens now, if you look at this, is that in system stored procs, these all are SP, but when you get to the bottom of the list, you'll find entries in here now that start with XP. And similarly, if you go to extended stored procs, the end of the list is still XPs, but there's an awful lot of SPs in here. So even though it seemed like a good scheme where they had SP and XP and so on, because just the way things evolved over time, they've now actually got them wrong in both of the sections. And so this is actually a really, really poor outcome. So look, my preference on that is not to use those. I also want to encourage you to make, as I said, good use of schemas, because again, sticking everything in a DBO schema nowadays is just not actually a very sensible way of doing things. And importantly, schemas can be a security boundary as well, and that can be very, very helpful to you when you're trying to set up and secure systems. Obscurity in the naming of things is not a virtue. It's not something I'm a fan of. This is an example here of tables on a system I was working with a while back. And these were the names of the tables. I have no idea what that abbreviation stood for. The things on the right are my attempt at working out what they meant. But this is ridiculous. I mean, I do not wish to work with a system where that's the situation. And creativity, even though you can do some things, everybody says even though you can, maybe you shouldn't, right? So this is a list of databases in Object Explorer, but notice that this clever soul has named the database after the path to the database, right? So if you had to use that, I mean, you can put it in square brackets, you can pretty much do what you like. But if you tried to use this, you'd have to be going like use open square bracket, X colon, blah, blah. I mean, that's just ridiculous. And so you've got to avoid that sort of thing too. Now, in terms of data types, you need to be consistent and you need to use appropriate types. So the first thing is don't use any of the deprecated data types. So we don't use text, don't use ntext, don't use image. So for text, we use varchar max, ntext, we use nvarchar max, and image, we use var binary max. But also, try and be consistent about the lengths of things. Often I go to systems and they'll have a phone number, and in one place it's 20, in another place it's 15, somewhere else it's 12, and so on. That's ridiculous. I mean, you need to go through and try and make sure you have that sort of consistency happening in how you've designed things. And if in doubt, to give you an example, I was at a site a little while ago where they were storing an email address, and the person who did it just had no idea, so he just said, hey, that's going to be 1,000 characters long. But the problem with that is then it's difficult when you start creating indexes on that. You're going to get things saying, hey, index keys can't be more than 900 bytes in earlier versions. Nowadays it's 1,700 bytes. But this is because they picked a silly length for things like that. Now, if in doubt, the first thing you always need to do is try and find out if there's a standard. And of course, that's the right answer, is to go and look up a standard and work out how long these things can actually be and use that. Now, another one is that I wish it wasn't true, but strings are really slow to sort in SQL Server. Well, I mean, it does a good job, but compared to numbers, strings are unbelievably slow to sort. And it makes sense, because you can imagine if you look at collations, you've got all the rules that are used to compare characters. And so if I have to compare two strings, I get the first character from each string, I have to apply all the collation rules, and then I move to the next character, and then I apply all the collation rules again, and so on. That's a really heavy-duty process doing that. And so, as I said, I wish you could just forget that and just use strings wherever you felt comfortable with that. But if you want something to really perform, in many cases, you really are going to have to think about using numbers for things where you're doing lookups and so on. Or you also need to avoid unnecessary sorts, like putting distinct over the top of a query when there's a large number of columns there that are string columns. We tend to avoid money and float. Money is an old Sci-based data type that's been around a long time, same with small money. We tend not to use it. Well, we use decimal instead. I understand it must be tough for a developer who looks at the list of possible data types, thinks I need to store currency of some type, and then there's a thing there called money. I mean, it seems really obvious that's what they should use, but unfortunately it really isn't what they should be using. You should use, we use decimal instead, and you need to exert the right control over the number of decimal places that you're going to be working with that, where money has a fixed 4 decimal place thing, and it can really end up messing up things in terms of rounding and so on. A float generally doesn't have a place in business applications. There's a few spots where we tend to use it, but one of the mistakes I see is I see people, developers who are coming from Java in particular, and whenever they think I need to store a number that has a decimal place in it, what they'll do is they'll make it a float instead. And these are the people that often have columns of numbers and things that don't add up properly, right? So just to give you an example of that, if I said declare at counter, or let's call it value, as float, and I'll make that equal to 0. And if I say, look, while at value is not equal to 10, again, go print at value, and then go set at value is at value plus 10 cents. And then the question is, how many times or how long would that execute for? Now, I mean, in any reasonable expectation you might have, you think, well, that'll just print values, 10 cents at a time until you get to the biggest number. But notice if I run this, just doesn't stop, right? And so if I stop that, cancel the query, and we look at the values that have gone on here, it started doing the right thing, then notice what happened here is that we actually had that value, but it didn't stop there, right? And that's because, unfortunately, when the value was 10, it wasn't exactly 10. And so, and the problem here in this case is that 10 cents can't be represented properly in binary. It can't, exactly in binary. And so the problem is it's an approximate value, and so you never quite exactly got to 10. And so there are ways you could avoid this, like you could subtract these two values, do the absolute value, and then see if it's less than a certain amount and so on. But you don't want to write code like that. I mean, so if you're dealing with like money values and things like that, I mean, if I said that's, decimal 18,2 or something, you run that, and that's just going to run and stop exactly as expected, right? So, so you don't want to be dealing with those weird rounding things. But as I said, I often see that where people particularly have come from Java, where they end up sort of assuming that's how you need to do it. All right. Now, we also we have some free tools called STU tools, and I just highlight here that there's a whole lot of functions we have that can help you go through and tidy up your databases. So we have mismatched data types. So the same column name in different places defined differently. Or show me all the data types, or show me the deprecated data types, and so on and so on. Find subset indexes. Now, another one is constraints. People often design tables, but they don't add appropriate constraints. But they matter, right? And so, to give you an example, if I had some sort of countries table, I might have a column that says the country code is USA, or actually let's say PL or something for Poland. And then I'll have a country name that's Poland. But what you'll see when the people design the table is this might be the primary key, or they might have another number that's the primary key. But the thing is, it will be by default, it'll be defined as unique. But the problem is that if you think about this value, the country name, incredibly likely that that is unique as well. But what will happen is people won't add a unique constraint to it. Now, where this ends up being a problem is that if you're using something like a query tool, and I had to add up all the sales in a sales table where I've got amounts of money, I've got the country code associated with it. If I was writing the query, I would add all these up, whatever. But what I would do is I would group by this code. Problem is that people who are using a query tool, they won't do that. They'll actually group by this. So because they know that in the output, what they want is the output by the country name or something like that. And if you think about what has to happen, if I do that, then what happens is SQL Server has to get every line, every row in that sales table. It has to join it to the countries table, get all of the answers, and then it has to sort the entire list of rows by the country name to be able to then do the grouping, just to be able to return the results. Whereas if you had a unique constraint on that column, then SQL Server is clever enough to know that it could just group by the code and then go and look the name up at the end. That could have a profound impact on the performance of the query, and the only difference is that you had a unique constraint on that name. Yep. And so, but as I said, so people tend to, maybe if they do keys and things properly, the problem is they forget to add other appropriate constraints. Now, another thing I do with constraints as well is that in many cases I try and have a name for the constraint that gives you an indication of what the problem is. So if I have a check constraint that says, the credit ID or something must be between 3 and 10, I could create a constraint that just has some random name. But if an error occurs where somebody tries to put a different value in, they're going to get a message that says, the insert failed because, a constraint, and then some weird name, was basically violated, right? Whereas if you had put something in there where, as part of the name of the constraint that described what the problem was, that would actually turn up in the error message and make it a lot easier for the person using it. All right. Now, the next thing is in terms of concurrency inside the database. Databases try to give you the illusion that you are the only one using the database. Unfortunately, that isn't a perfect illusion. And so you end up being affected by other users in the database. So apart from performance problems, one of the other things that we get called in to look at in sites all the time is people say, I have a locking problem. Or if they're a little bit more nuanced, they might say, I have a blocking problem. Often when they say they have a locking problem, we get there and they just have deadlocks and things happening all the time. But look, locking isn't something you avoid. It's actually an important aspect of the database. Really important to understand, though, how lock escalation works and how the different locking modes work. You need to spend time getting your head around them. They make perfectly good sense, and there are good options for dealing with the issues. Obviously, the thing that I'd say is if you find that no lock in your queries is the answer to your problems, you're probably asking the wrong question, right? So it's fairly rare where I would use no lock in a query. Where I do that is if I have some sort of like production machine that I cannot in any way end up locking or causing any sort of problem to whatsoever, and I cannot change the code that's running in that machine, then I might use a no-lock just and deal with the consequences. But, if your normal approach for handling locking is putting a no-lock in, then this is a problem, right? Because what you're saying when you're using no-lock is you're saying, I don't want to take any locks and I don't want to honour any locks that are already there. And that's fine, but what you're doing is you're trading off consistency for performance. And so, for example, if I'm using no lock, if someone starts a transaction, inserts a row, I could read that row, and then they could roll back the transaction, and then this is really weird, because suddenly I've got a report that has a row in the report that never existed in the database. That is really hard to explain later to someone. Another one is that I can have a query that's running along an index and something else could pick up a row from in front of me in the index and put it behind me. So I would then just completely miss that row. Or worse, they might take a row from behind me and put it in front of me. And all of a sudden I have the same row twice in my report. Or they might move it again. I could have the same row 3 times or 4 times. And so it's really, really hard when you look at a report and you go, hang on, that row never existed. Where is it? It's nowhere in the database. Or if you have things where you go, why is this row included twice or 3 times? Or why did you miss this row? These are the sort of things you start having to discuss if the way you've done things is to use no lock. Now, it's important also with concurrency to learn to recognise and avoid race conditions. One of the most common sort of things I see people do when they're new to this type of development is people will select a value from a database, they will add something to it or do something different, and then they'll just write it back into the database. Now, clearly that's fine if you're the only person using the system, but you've got to try and avoid those race conditions, and they're really, really easy to do. So, to give you an example, if I was writing code to archive some data out of a table, the traditional way to do that is I would do a select, so I would do an insert select to select the data out of the table that I'm going to remove and insert it to the archive table. Then I would run a delete statement that then removed those rows using the same predicate. But the problem with that logic is that I don't know absolutely that the rows that I inserted off to the archive table are the same ones that I just deleted, because it could potentially have changed in the meantime. Now, TSQL has ways to get around this. So, for example, what I should be doing is I should be doing a delete statement with an output clause. So as I delete the rows, they're being output into another table. That's how you do the archive, not do an insert select and then do a delete, right? So you've got to start thinking about, when other people could be using this, how do I use the database? And importantly, there's a concept of isolation levels. You really need to get your head around those. Another one is dealing with connections, right? And what this is about is that we always, when we think about connections between our applications and the database, we just want something that's solid, reliable, high quality, and so on. But the problem is, just like real networks, the reality is often really, really different to that. And so we can have problems, right? And so what you need to do is you need to not write your applications assuming that everything will be okay on the connections. You need to plan for failure. And then you'll be happy when it works as expected. But the thing is, you plan for the fact that things go wrong. Now, I go into organisations all the time, and the organisation has spent an enormous amount of money buying highly available systems. But the minute the system fails over, maybe the primary server fails over to the secondary, just like it was designed to do, every application in the building breaks. Now, so the question is, did the developers do their job? The answer is no, right? And so the question you've got to say is, if I'm connected to a server and there's a failover occurs, what does that look like to the application? What it actually looks like is that the server just disappeared for a short period of time. And so the question is, can you write code that can talk to a server on the basis that you know that maybe the server can disappear sometimes? And the answer is yes, you can write that sort of code. But the problem is, it's not going to happen automatically when you do that. So you have to plan for that in the code. And so you also might want to think about isolating different workloads inside your application. If you have things that need to be read-write, perhaps they use one connection. But if you have something that is just doing reading, and it really is read-only, and it can deal with a bit of latency, so after the data's updated, within a few seconds or something, you can read that, you might want to consider having a second connection for that. And then when you get up to larger scale systems, you could point the read-only workload off to a secondary server or something like that. Also, try and avoid using actual server names. So I see people build applications, and in the application, they need to connect to a server called, DBL XYZ ABC. And the problem is that name ends up in their application. If they're a bit better, they have some sort of configuration file, and that server name ends up in the configuration file instead. But the problem with that is that if you need to move databases between servers and things, again, you've got to go and find all those configuration files. That's not the best thing you could be doing. So what would be better is to say, oh, hang on, that's the HR server. And what you do in your application, even in your configuration file, is you say, connect me to the HR server. And then you let the environment deal with the difference. So maybe via DNS or via SQL aliases or things like that, you have something that then maps the word HR server across to where the real server is. Now, the beauty of this is if you're working in different environments like developing, testing, UAT, production and whatever, then you don't need to change a single thing about the application because the environment can connect you to the appropriate server rather than you even having to change configuration files. Now, another one is retry logic. And so when I worked with these when I was quite young, they didn't have handling of deadlocks. And so the typical scenario is I have some resource A, I want resource B, somebody else has resource B and they want resource A. That's never going to get resolved, right? One of us has to give in. Now, and it's usually not necessarily even just two people. It might be, I've got A and I want B, somebody has B and they want C, somebody has C and they want A. Could be any number of users in there. But what ended up happening in those old systems is that when the first two people had that sort of situation, they'd freeze. Then the next person who tried to access one of those resources, they'd freeze. And then another person had accessed something that one of those had, they'd freeze. And so on. And they used to call it creeping death syndrome. And so what would happen is you just have machines one by one all around the building just suddenly freeze up, right? And what you'd have to do is go and find the head of the blocking chain, kill that session off, and then all of a sudden everybody came back to life. And so they decided when they designed SQL Server, they didn't want to do that. They wanted to have this automatically dealt with. And so they have a thread that fires up very, very regularly and looks for these sort of cycles. And when it finds a cycle, it resolves it. And a resolve means that some session has to die, right? Now, when they first did this, they used to do it on the basis of whoever had just put the last link in the chain. What they do nowadays is they look for who has written the most log records. They're the one that gets to live. And so the idea is that the more log records you've written, the harder it is going to be to roll you back. So they'd rather roll back someone who's done less, what they see as less work. And so this is how it's sort of handled nowadays. But if you think about it from an application point of view, if I go and execute a query and it comes back with a deadlock, the question is, what should I do, right? Now, there are things I can do in the database nowadays to trap and retry that. But even from the client point of view, if I have that sort of scenario happen, all I really need to do is to sort of back off, wait a little while, and try again. But you have to start thinking in an application about how you talk to the database. So instead of saying, have a connection open, instead of saying, start a transaction, do the work, commit the transaction, and hope for the best, what you need to be building code is more like, while I haven't submitted this transaction, let me try and put the transaction in. And if it fell over, for, in this case, a deadlock, let me try that again. Now, usually what you do is you don't try it again immediately. You have a progressive thing that backs off for periods of time and so on. But what it means is, from the user's point of view, they shouldn't see a failure. But there's so many systems, where people even get the actual deadlock message saying you've been chosen as a deadlock victim, which users really don't appreciate, right? Nobody likes being chosen as a victim. But the thing is, even if it just gives an error message or something without that sort of text, the thing is, most of the time, the user shouldn't see a failure. You should be able to handle that. Now, part of the reason why I think it's important to consider doing that in the client is that there are other scenarios that you need to think about retry for. So if, for example, you have errors, checksum errors like 823, 824, what that's saying is, I read from the storage and something went wrong, right? But the thing to understand is that ever since they had database mirroring, and now with availability groups, you have the potential that that page will get rewritten from a valid copy of the same page. And if you try that same query again later, it might just work, right? And 829, for example, says this page is in recovery. So it means it knows that something's on the way back. Error 3960 is one caused by snapshot isolation. It's a violation due to snapshot isolation. Look, there are several scenarios here, but you need to think about in your client code, can I deal with the server disappearing for a minute because a failover has occurred? Can I deal with deadlocks and so on? There's lots of things where you might just want to back off and have another go, after a period of time. But if you've written your code to always assume that just try and hope for the best, that isn't going to work. Now, also get used to T-SQL. A lot of people, it's almost like people think it's an odd thing, but you need to spend some time learning T-SQL. And big hint, it has changed since SQL Server 2000, right? So there's a lot of things you can do today that there were much, much harder ways or not good ways to do in the past. It's important to learn to think in sets. Again, there's so much procedural code out there. I understand that, that's how people think in many cases, but it's really important to learn to think differently to that. Don't use old style joins. Try and use the ANSI 92 style join syntax. So don't go from table, comma, table. Instead, go from table, inner join, another table, on, and so on. Use that style of join. There's a number of common T-SQL issues. I see people, when they need to do an exists, actually do a count. And so, is there a transaction for this customer? And what they'll do is they'll say, go and count all the transactions for the customer and then see if that's more than 0. Well, that's not clear to someone reading it, and you run the risk of that not being optimized by the optimizer either. Select asterisk obviously is rarely a good idea because what you're returning when you do that is a whole bunch of columns, and the problem is that you know which columns you're going to make use of nearly all the time, and if somebody adds additional columns in the back end, you don't really want them being returned in your query. Distinct doesn't fix your join issues. When you're writing a query and you're getting more rows back than what you're planning, don't just go and stick a distinct at the top of it and hope that'll sort of fix the problem. You need to get to the bottom of what the problem is with the join. Also, I see people using union all the time to group, I do one select query, I go union, I do the next one. And in many cases, the problem is that union in SQL Server is a union distinct. We can't actually say union distinct, but after it does the union, it does a distinct operation on the entire set of data. And so in many cases, if you already know there's no duplicates and you're grabbing data from different spots particularly, then it's really important to make sure you're using union all rather than union. That can avoid a massive sort of sort operation. It's important to consider performance of feature. So there's lots of optimizations. If you think about, if I'm grabbing data from elsewhere, bring it into a staging database, a set of staging tables, and then I'm processing them into another database. Maybe the main database needs to be in full recovery model, but perhaps that you could have a separate staging database that's just simple recovery. So that way, if you're just endlessly trashing what's in the table and loading it up again, then that's fine. Then you're better off having that in a separate database rather than having full logging occurring for the whole thing. You also need to optimize common use cases. I come across situations all the time where people have screens where users can pick any combination of things, and the developers tell me they can't optimize the screen because they don't know what people are going to pick. Well, you might not know that right up front when you're designing, but the problem is if you monitor that down the track, what ends up happening is users don't use every possible combination. They tend to use a handful of combinations. And so what you can do to make yourself a hero is detect when they're using one of those common use cases, and you can optimize that scenario. Now, if they happen to pick another scenario, that's fine. You end up running the generic query and it takes a while. But if you've fixed the majority of the standard ones, then this is really important. And it's also important not to sort of over-design things where you're not making the normal stuff work properly. I was at a company who do flight bookings years ago, and they had a procedure that used to take a ticket number and it would run in about half a second. They kept adding optional parameters to it. They got to like 4,000 lines of code. And every time they ran the proc, it took a minute and a half. Now, the problem with that is that when we did tracing, in a week, we didn't find a single situation where they ever passed anything except the ticket number. So for a scenario that never happened, they turned their queries into, something that just ran so slowly. Try and avoid query hints. Indexing isn't a job for somebody to do later, right? And most single column indexes are usually pretty useless. So I see people who don't know about indexing and they just start indexing all sorts of individual columns and so on. That's not a great idea. Filtered indexes can be really interesting, but you need to be very, very careful with filtered indexes. In particular, whatever is in the where clause needs to match exactly what you have in the query and not with variables. Right? It needs to be able to do that very directly. And don't just go and add all the indexes suggested by the DMVs. We've got these missing index DMVs nowadays. I love the fact that the default name is name of missing index, and I've come across that now in a number of systems where people have just created it and they have an index called name of missing index. But also when you're optimizing it, don't go optimizing for sort of small data sets when you're actually going to be working with large data sets. And, as I said, avoid blind faith in the tools. We do have tracing and indexing stuff. There's a free course we have, which is called 4 Steps to Faster Apps. If you don't know anything about tracing, at least it'll get you sort of on the right track with that. And then if you need to know about indexing, we have stuff there for that. Now, a few final things I want to mention. Design-wise, Agile isn't a synonym for sloppy, right? I see people all the time who do really sloppy work, and their excuse is they had to be Agile. And what they end up building is the exact opposite of an Agile system. Randy Knight, actually, I loved his quote, where he said 95% of his business was fixing performance problems from Agile teams. I like to have at least one layer of abstraction in the database. If your applications are going and hitting tables and things directly, then you really don't have a great structure. And I go into organisations all the time where the people who look after the database feel like they can never change anything. And it's because they have no visibility in the code that hits the database. And so your data models as well, you don't have to have in your application a data model that matches the one in the database. You need to think maybe that's not a great equivalence. AdventureWorks doesn't represent best practice, right? And so I see people use that as an example all the time. But keep in mind, it was designed for a different purpose. It was designed to use every single feature in SQL Server. So that makes it the least typical database that has ever existed, because they've forced design decisions in there to try and use all the different features. I was the person who built wide world importers, and I think it's a lot better, but I still had to make a large number of trade-offs from what I would normally do just to satisfy the product group. Now, also online advice, just keep in mind a lot of it's wrong, and the other thing is it ages quickly. So something that was true at one point might not be true today. So make sure you take note of how old the advice is, and consider having someone who really knows data on your team. If there are built-in features, don't roll your own. So if you're going to have queues, use Service Broker. If you're doing security, building your own is almost always a bad idea. And so, look, I'll show you a couple of things with security, and then we'll just close out. Some of the things I see in security are amazing. This is a screen that came up, and I was changing the password, and it said the old and new passwords are not the same. You think, oh, yeah, thanks, okay. But I love this one. Actually said the password already exists for another user. Do you want to use it anyway? Oh, really? That's just so appalling. It's hard to describe how appalling it was. This one here asked me my father's middle name. I said John, and it said you need to have at least 6 characters. Don't build this stuff yourself. It's just not a sensible thing to do. And so, look, if you want to get some background on a lot of these things, up at my site, I've got a whole lot of podcasts, including with Camel from the Polish community, originally now in Britain. But there's a whole lot of interviews there with people that I think are interesting in the community and could give you some really good feelings on how you should be using the product. And so, look, I thank you for attending. So Greg at SQLDownUnder.com. I know tight time-wise, I'd love to sort of hang around and do a whole lot of questions, but what I would suggest, because I don't want to run you into the next session, What I suggest, just feel free to ping me with any of the questions for anything that came up in the session. And I'll leave it there because, we've got notes from the session. If you want the tools, the free tools, just go and grab them from there. There's a SQL Server Management Studio ebook. I've got a bunch of ebooks there now on TDE and things. Feel free, just grab all of those. The podcasts are there, my blog is there, and we have training. So look, don't be strangers, stay in touch, and I hope you will have found something useful in the session. Thank you.